I would like to acknowledge my co-authors, Jared and Dan, who were not able to attend the meeting for various reasons. They really did the bulk of the work preparing this presentation that I'll be giving. It's an update on a 3-year study that collaborative study between USGS, U.S. Fish and Wildlife Service, and Wisconsin DNR, looking at the spawning Cisco populations around the Apostle Islands area. Many of you have probably seen this graphic previously, but it's commercial harvest by jurisdiction in Lake Superior and the rapid increase in harvest in Wisconsin waters, really due to multiple factors. The driver was increased demand for Cisco roe due to basically decline in Vendis stocks in the Baltic Sea, another core-gonid in the Baltic Sea. What's different about Wisconsin is that there was very limited regulation on the Cisco fishery, and so what it's already a large fleet could immobilize more effort and capitalize on better, basically, market prices for Cisco roe, and you can see that resulted in almost an exponential increase in harvest. This whole subject of the increasing fishery in Wisconsin and potentially declining Cisco stocks within Lake Superior has drawn the attention of different media outlets. First, kind of talking about the increased demand, because of the Europeans' taste for caviar, but then more specifically in Minnesota waters, where their fishery is certainly concerned about what's happening in neighboring jurisdictions, but then also just the overall declining size of Cisco stocks, really due in part to a lot of the things that Mark Vincent talked about this morning, which I'll kind of elaborate on again. Big part of the concern for Cisco stocks is this graphic. It's the recruitment index from USGS bottom trawling. We've known for quite a while that it seems like inherently the Cisco stocks have sporadic year classes. The more concerning part of this graphic is the declining magnitude of those year classes that we are seeing. And in a case like what you'll see eventually, what proportion of the fishery is made up of these year classes and these smaller magnitude year classes. So back in 2013, when this project was just starting to take off, we had information on the size composition of the suspended gillnet fishery. It looks a lot like what Beth presented this morning as far as the size distribution, but the story is really when you look at the age composition. And you see that the fishery is being supported by 3 year classes and actually really predominantly by one single year class. That's very concerning for any fishery, but especially one that's increased to the degree that it has. Fortunately, a lot of effort and research has been put into the dynamics of Cisco on Lake Superior, really largely supported by the Lake Superior Technical Committee. And my colleague Dan Ewell and others in his shop have put a lot of time and effort into determining what optimal sampling methodology would be for spawning Cisco stocks. And so we weren't starting from scratch. It was really just applying these various research methods on a specific stock in the Apostle Islands. Having said that, we knew right off the bat that we needed to be strategic about sampling. There was no way that we could sample all of the Apostle Islands in a given year. And so we began to look at commercial harvest. This is by grid. And what stuck out immediately is that somewhere between 85 and 95% of the harvest in a given year was taking place really in 3 statistical grids. 1208, which is kind of north of Sand Island, which is kind of the western portion of the Apostle Islands. 1307, which is a grid outside of Cornucopia, kind of a historical fishing grounds. And then grid 1410, which is east of Madeline Island. And so, again, to be strategic, we said we were going to sample those 3 grids and then a grid adjacent to those where there is some level of harvest, but not nearly the degree of harvest in those three primary grids. So the original study design was basically in 2013 we would sample the 2 grids within Section A, 2014 Section B, and then 2015 C. We were successful in 2013 sampling grid 1306 and 1307. However, in 2014, everything that could go wrong with vessels and weather basically did. I mean, November's a terrible time to have to sample, but then we had vessel issues with the Kai and Wisconsin DNR's vessel, and so we only got out one sampling occasion, and actually the decision was made to sample in 1307 again, really due to the preliminary findings in 2013 to try to validate if there was a trend going on there. So going into 2015, the data mostly that I'll be focusing on today, we had a lot of catching up to do. We not only wanted to do some repeat surveys in 1307 to look at temporal trends, but then also to try to visit those other grids identified to see what the Cisco fishery, the status of the Cisco fishery was on a broader scale. And so kind of revisiting the study objectives. The first part of it was more, again, thinking about methodology. And an underlying question was, could you do surveys like this without the assistance of USGS and their giant boat? Could you collect hydroacoustic, comparable hydroacoustic data off small vessels that are retrofitted for hydroacoustics, and then could you apportion that data using gears other than midwater trawls or bottom trawls? And then a more basic question, although very important for managers, was what's the current status of Cisco's in the Apostle Islands area? So in 2015, Dan had done some work up in Thunder Bay with OM&R, where basically similar transects were followed with with a short duration in between transects. Basically, one transect was taken with the Kai, and then a similar transect was followed with a smaller vessel that was retrofitted for hydroacoustics. And what you can see is the estimates of acoustic densities on the right side correlate pretty well between the data collected between the two vessels, which the acousticators tell me that's not necessarily the case. There could be, the quality of acoustic data could be compromised by the noise from a vessel or other factors. And so we were very encouraged to see that, at least comparable acoustic data could be collected off of vessels not necessarily designed to do so. The second portion of that was, could that same data, the hydroacoustic data, be apportioned using gears other than a midwater trawling and bottom trawling? And so in 2013, we had basically applied float gill nets and bottom set gill nets in close proximity to areas that had been trawled by the USGS vessel. And you can see again, comparisons of abundance estimates for males and females were not statistically different between the two apportionment or the two gears used to apportion the hydroacoustic data. So again, what we've learned is that an agency like Wisconsin DNR could collect the data, the hydroacoustic data off of their gillnet tug, and then set gillnets to apportion that same data set and come out with similar estimates than would be collected by USGS. Another sort of thing, it became routine, I guess, as we do these fall surveys to pair commercial catch per effort information and look at kind of what that looks like in relationships to when the sampling was done. And so the vertical lines on these two graphics are when the spawning surveys were done. The underlying assumption being, at least ours was going into it, was that commercial catch per effort was fairly highly correlated with density in that area, at the grid level. And so you can see the timing of the survey in 2014 was quite a bit later because of all the problems I mentioned. And so we weren't exactly sure how much influence that might have on estimates of abundance. Earlier studies seem to suggest that you could sample throughout the month of November and you'd get similar estimates of spawning abundance, but maybe there's something going on in later December. I mean, you look at these catch per efforts, they're gigantic in November, well over oftentimes 1,000 kilograms per kilometer, but then double, triple as we go into the month of December. And so going into 2015, we want to do repeat surveys in grid 1307 during the course of the spawning season, match those up with commercial CPUE and see if there is a high correlation between density estimates and the commercial CPE. But then also visit all the statistical grids, the 6 that I had identified early on, and get a sense of overall status of Cisco's. We're somewhat fortunate, or especially Dan is, that doing hydroacoustic surveys on Lake Superior is relatively simple in that The species composition is relatively simple, and for spawning-sized Ciscos, they separate themselves out from the other species, pelagic species in the water column, very easily by size. And so as you start to apportion at least during the fall and in the depths that we're sampling, where the spawning congregations really are. And so if you look at the hydroacoustic targets versus, it's like a histogram of the targets basically, and using the threshold that Beth mentioned, that's kind of part of the Great Lakes SOP, a large majority of the targets that we were seeing up in the water column were below that or above that threshold, and were likely spawning size Ciscos. Alongside the surveys that we've done over the last 3 years, and actually even prior to the surveys, Wisconsin DNR goes out and does a lot of onboard monitoring and collects commercial data from the fishery. And so here's an example of the 2015 data collected from commercial monitoring, and you can see the two length histograms on the right, looking at length distribution, or on the left side, excuse me, show that many of the larger individuals are spawning size fish, and not surprisingly, being suspended nets, the majority of the actual fish caught are females. That's what the fishery is targeting. More importantly, what we had at our disposal was reported harvest by grid, and that's what's on the right graphic. And as in previous years, the majority of the harvest is taking place in grids 1307 and then 1208. And quite a bit less harvest in those other grids, even though they're adjacent to the two large harvest areas. So looking at the commercial CPUE versus the repeated sampling that was done in 2015, we see a very similar trend in commercial catch per effort going into the month of December, where it ramps up dramatically. And actually the largest, there's a dot, one of the last lifts in 2015 was almost 6,000 kilograms per kilometer. That's basically a single day's lift. Just incredible catch rates. And so, again, our assumption was commercial catch per effort highly correlated to densities, and so we expected to see our densities ramp up in a similar trend as commercial CPUE. And that wasn't necessarily the case. So each one of the bars on the lower graphic is a sampling event, and outside of one sampling event towards the end of November, the densities were remarkably similar across the time period. What you'll notice looking at the top graphics, though, is that on the grid scale, the distribution changes. Not surprisingly, fish move, but there's probably things going on where they're congregating in certain areas, maybe due to spawning behavior, or as maybe groups are moving in. But the actual densities for most of those sampling occasions were not any different. Probably most surprising, if you would follow the trends of commercial CP, we would have expected very high density estimates in December. We've had a lot of discussion about what this data means, and certainly not have we come up with any true hypotheses, but we're starting to dig down into the commercial data. Is it a catchability issue? Is it actually fisherman behavior? We were looking at effort by some of the fishermen, and certain fishermen are dropping out of the fishery in December, and possibly it's more fisherman behavior than it is necessarily higher densities that are driving those commercial CPEs. But luckily we have a lot of information by sampling almost weekly throughout this time period, and we're going to try to look at some resampling of the data to see not outside of what the trends might mean, but minimum sampling as far as length of transect, whether the grid scale is the most appropriate measurement level. Certainly looking at this, it would suggest that that's the case. If you measured these stocks on a smaller, more precise level, say the northwest part of this grid, you could see the densities there would vary dramatically from one sampling session to the next. But at least at the grid scale on 1307, it was fairly static over time. So where does 1307 stack out? We were fortunate in that grid to have previous sampling events, basically due to other projects that have gone on in that area in the past. And you can see that 2013, 14, and 15, the density estimates for spawning size females was quite a bit lower than in previous years. And if you pair that with the commercial sampling data, or the reported harvest, and you look at commercial exploitation rates, in all 3 of those years, we exceeded the 10 to 15% exploitation rate that was suggested by, or is kind of the safe harvest list limits suggested by the Lake Superior Technical Committee. There was a lot of contention around the 2013 estimate, but I think the overall trend is that throughout those 3 years of sampling, we were above those suggested exploitation rates. So moving away from a grid 1307, kind of looking at the entire Apostle Islands region, you can see moving the bar graph, the density estimates on the left are moving from west to east, just as the bubble plot is on the map. And not surprisingly, the highest densities are in areas like 1307, 1208, where the majority of the fishery operates. The fishermen know where these fish are. Certainly there's areas that we weren't able to sample that may hold similar numbers or similar density of Cisco, but where fishermen can fish consistently, that seems to be where the highest densities are. If you pair that information again with reported harvest, you see that the exploitations rate for spawning size females was outside of 1307 was at or below the 10 to 15% recommended safe harvest limit. And in 1307, as I had shown before, was exceeding that exploitation rate once again in 2015. So we've shared this information on multiple occasions with the resource agencies in Wisconsin waters, and certainly we hope that this information will aid them in making decision making in terms of future harvest controls on the Cisco fishery. The next phase of this project, as we see it, is we were recently funded to do a project with the QFC in developing stock assessment models for Lake Superior Cisco. Looks like at this point we may focus initially more on Thunder Bay stocks, where there's a really nice data set of commercial age and aging information, etc. Develop a model there, and then that will probably help decide if we have adequate data in other areas of the lake to develop stock assessment models or make recommendations on what data might be necessary. Also using these stock assessment models to test different or evaluate different harvest policies is for Cisco. I mean, we have that recommended 10 to 15%, but that really hasn't been tested necessarily outside of recommendations based on, a lot of it really had to do with the life history of Cisco's in Lake Superior. So we feel like it's a really nice example where science will help decision makers practice good fisheries management. With that, I would love to answer any questions you guys have.